So like on 7 where it says, so if we just look at 7a, the original graph for A is going to look something, it's flipped and up 2, so 1, 2, so it's going to look something like this. So if there's the original, so all of your, so it's going, what's going to happen is it's going to reflect over this line. Okay, so your x and your y values change. So like instead of it being at 2, 0 or 0, 2, it's going to be at 2, 0. So it's going to look something like that, going in the negative direction. So is the red one going to be a function? What does it have to do to be a function? Pass what? Do you remember?
No.
Vertical line test?
Oh yeah, it doesn't have to like
so if it hits it more than one spot on the new function,
okay, so
it's not a function. So then, same way with the other one. What, 3x minus 5, so 1, 2, 3, 4, 5. Up 3 over 1. One, 2, 3 over 1. So it's going to look something. It's not what I wanted. Something like that. Similar. Not perfect, but it's pretty close. So then if I flip it, it will be a function because it's a straight line, so it's only going to hit at one spot. Okay. The easy way to check without drawing the second one would be to do what's called the horizontal line test. If it only hits at one spot, it's going to be a function. The inverse will be a function. B is the easier of the two because all we have to do with, like on B, is just cross multiply because we only have, all we're going to do on B is just cross multiply and go x minus 2 times x minus 4 and then do the same thing with the x minus 6 and the x plus 5. Set them equal to each other and solve for x. The nice thing about this is the x squareds are going to cancel each other. So then you're just going to be dealing with an x and then you go from there. So do you need to see 21b or yes? Okay. So x minus 2 times x minus 4 equals x minus 6 times x plus 5. So when we multiply, we get x squared. That's negative 4. Negative 2 is negative 6. X plus 8 equals x squared. That is 5 minus 6, so negative 1x minus 30. So solve for x. You have an x squared on both sides, so that's just going to go away. So let's make it easier. Well, you can do it really however you want. even if we just add 1x to this side and subtract 8 from the left, so if I add 1x, so I have negative 5x equals negative 38. Divide by negative 5. So x is equal to 38 over 5. With 18a, I'm going to kind of do, since I don't have a whole lot of room here, I'm going to do as much as possible. I'm going to factor, so I have x squared minus 9, so that can factor to be x minus 3 and x plus 3. I can't do anything here. I'm going to factor the top right and have x minus 3 and x minus 3 again. Then I'm going to factor the bottom right. I can take out a 3x, leaving me with 2x plus 3. Now I have to know what x can't be. So to start, as far as my restrictions are concerned, they can't be 0. Okay, because of the 3x. And then they cannot be a negative 3 halves, because it's opposite of the back divided by the front. So now I'm just going to do keep, change, flip. So I'm going to keep the first fraction, so I'm going to have x minus 3, x plus 3, over 2x plus 3, times, so I keep the first fraction, change the sign, and then flip the second fraction, so I have 3x times 2x plus 3 divided by x minus 3, x minus 3 again. So from here, now it just becomes getting rid of what's the same. So I have an x minus 3, I have an x minus 3. I have a 2x plus 3, and I have a 2x plus 3. So the only thing left on top is then 3x times x plus 3 all over x minus 3. Do not forget the restrictions. So with the restrictions, x couldn't be 0, x couldn't be negative 3 halves. Now with the x minus 3 on the bottom, what can x not be? A positive 3. Oop.